All right, our table is all set. We're ready to look at the process of the simplex method. So what we want to do first is determine which of these values in the last row is the most negative, okay? The smallest value, and that's going to be this one. Negative 12 is less than negative 10. It's the smallest value here. It's the most negative value here. So it's going to be called our pivot column. All right, so the first thing you want to do is determine what is called your pivot column. And you're going to see why in a minute. All right, after you've determined your pivot column, most negative, you now need to determine your pivot row. So what we're going to do is we're going to come over here to the right of our table and we're going to write the word ratio about right there, ratio. Put a line underneath it. What we're going to do is we're going to look at the ratio of what? Well, the ratio of the constant, which is 12, with respect to the value in the pivot column in the same row. So we're looking at the ratio of this constant, row number 1, with respect to this 2, because this 2 is in the pivot column also in row number 1. And that ratio is equal to 6. So just stay with me, and you'll see where this is going, I hope. Let's look at the second row now. So second row, let's figure out the ratio here. That's going to be 24 to 2. So this divides to give us 12. All right, so the significance of these values is that the smallest ratio, which is 6, 6 is less than 12, this is our smallest ratio, this will give us what is called our pivot row. Not pivot, cheese. So pivot row, okay? So you're going to do this every single time when you're trying to determine what. Well, here's the what. The reason why we came up with our pivot column and then our pivot row is that the intersection of the column and the row will generate what is called our pivot entry. Okay, so the first part of the process of the simplex method is to come up with what is your first pivot entry. And then what you'll do at this point is, if this is not already a 1, you're going to make it a 1. Then after you make this a 1, you're going to zero out everything else in this column, just like you did when you learned row operations back in chapter 5. Remember Gauss-Jordan elimination? All that stuff is going to come back now in this section, simplex method. So I'll walk you through those steps. All right, so again, once we've determined that this is our pivot entry, we have to make this a 1. If you've forgotten how to do that, I encourage you to go back and look at the notes over section 5.2. All right? Look at those videos, not only with respect to the process and the notation, but also looking at how to use your calculator to perform row operations, because you'll be allowed to still use your calculator to perform row operations if you like. I'm not going to go over that again. I, again, would go back to 5.2 and review those videos. Okay, with that being said, how do I make this a 1? Well, remember, all we're going to change is row 1, so you just write down the reciprocal of this, whatever it is, and then multiply it by row 1. So the reciprocal of 2 is 1/2. So your next table will be based on this row operation. You got to make this a 1. So you always just write down the reciprocal of that number times the row that you're changing. So that would generate what? That would generate this, 1/2, right? 1 times 1/2, 1/2 times 1, 1/2. 1/2 times 2 is 1. That's the whole point. And then so on and so forth. You're basically just multiplying every single entry in row 1 by 1/2. Okay, giving us this. Note you end up with that ratio that was the smallest ratio that we looked at earlier. All right, so this is the next table. At this time, you want to zero out the entries below this 1. This is exactly the same now as what we already have discussed in chapter 5. Again, review Gauss-Jordan, okay, review row operations. So what we're going to do now to make this entry and this entry a 0, to create what's called a unit column, is what? Well, let's write down a long arrow. And we're going to be changing row 2. So you write that down first. Okay, how are we going to change row 2? We want to make this a 0. So to review this process, all you're going to do is write down the opposite of that number. Whatever this number is, write down the opposite of that number right here, -2, times the row in which you just created a pivot entry, which is, of course, row 1. And then we'll do a couple of operations at one time here. So row 3 needs to change. We have to make this -12 become a 0 as well. So what's the opposite of -12? +12 times the row in which you just created a 1. And then you'll have to put some time and effort into this, folks. You have to write down these column headings every time. Doesn't take that long. I would say less than 20 seconds. So there's our table. Row 1 is not going to change. Only rows 2 and 3 are changing. So I'm going to go ahead and write down the entries from row 1. All right, have that row all set. And now I'm going to perform these row operations. Again, if you want to use your calculator to perform these operations, you are certainly welcome to do so. I would encourage you to, again, review those videos on how to do that. Okay, the size of your matrix, if you wanted to use that, your graphing calculator to figure this out, to use row operations with your graphing calculator, the size of this matrix will be what? 1, 2, 3 by 1, 2, 3, 4, 5, 6. The size will be a 3 by 6 if you're going to use your graphing calculator to perform row operations. All right, here's what you would get. You would get a, let's see, 3 minus 2 times 1/2. That's going to give us a what? It's going to give us a 2, I believe. And then here's the whole point. Row 2, moving on to the second column, 2 minus 2 times 1. 2 minus 2, in other words, is 0. That's the whole point. We're trying to create what's called a unit column here, which means there's a 1 and then zeros everywhere else. So still looking at this first row operation here, what are we going to end up with? A -1, I believe, and then a 1, and then a 0, and then a, I think 12, right? Yeah, because 24 minus 2 times 6. 24 minus 12 is 12, okay? Moving on to the third row, I'll just do a couple of these for you out loud. So -10 plus 12 times 1/2, right? So -10, first column, plus 12 times 1/2, that's 6. Okay, -10 plus 6 is -4. Okay, hopefully you're remembering this process. You get a 0 here, you'd get a 6 there, you get a 0 here, 1 there. And this last one, I'll go ahead and do this one with you. So the final column, row 3, 0 plus 12 times row 1. So that's going to be 0 plus 12 times 6, which is 72. Okay, so we've created a unit column. We're finished with really one cycle of the simplex method algorithm. Okay, we've completed one cycle of that. So with that being said, we just go through the motions again. And we keep going through the motions until every entry in our last row is non-negative. As soon as our last row has all numerical values that are non-negative, which would be a 0 or a positive value, then you're finished with this process. In this case, you can see that we're not finished with this process because we still have a negative value. That means we have to go through this algorithmic process of the simplex method one more time. So let's see how to do that.